motor running.
This is Andy Tube, and this video I'm going to open up this RF5 motor from my Singer Model 99K Cute, and you'll see it's a bigger motor compared to many of the other 99K models that you see around, but it is a Singer motor. Was made in Canada. The catalog number RF5-8. Now in most of the parts manual they just called this an RF5 motor, and then they had -6, -7, -8, and I think that mostly had to do with the amps of the motor. And this has a 0.8 amp motor. And the smaller motors, from what I've been able to tell, most of them were the BY15 motors. But I found a chart saying that different models and variations of the 99 and 99K had a BAK style, BRK, the BY I mentioned, and the BZK. And I don't know why the J is here, but it's not in the parts list that I came across and stuff. I know that some machines made in Canada, like say a 185, the 185J was the one in Canada, made in Canada. So I really don't know. But if you saw some of my early videos, all the wiring is what we call hardwired in here into this housing of the motor. And on the smaller motors, this bracket I think is called a K bracket. But on this motor, that bracket is part of the cover of the machine. And the cover has two pieces here. And it separates right in the middle. The same thing with the housing and everything. So the end with the pulley was called the end cover pulley end. Alright? And then the other end was called the end cover commutator end. And that's how they differentiated them. But there's two cover fastening screws that go in from the pulley end here. And they go all the way through all the parts of the motor to here. And on this end there is a couple of nuts just called the end cover fastening screw nuts. And I know my 11/32 socket fits them, but it's just a little bit loose, so I think they might be a metric size or imperial size. But anyway, if we take these nuts off, we can take the commutator end cover off, and it's just going to separate here, right? There we go. And let's just look at this end cover for a moment. The first thing I noticed was it reminded me of the PA style motors I'm familiar with on the 301 and 401 class machines. It kind of looks a lot like it, except there's some connector posts sticking up out of here. But take a look down in there. What's in the end of this is armature shaft bearing. If you can see the kind of bronze or colored in the center. and that is for the shaft to ride in. Okay, and then there's this big retaining clip. Let me get a pointer instead of getting my finger in there. You probably see enough of my fingers. There's a very strong retaining clip. I've took it out a couple times to see what it is and put it back in, and it's difficult to take out and very difficult to put in, so I don't bother with it anymore. I'll just clean this area out, you know, the bearing out with a cotton swab and some alcohol or crud cutter cleaner. And then I usually will put a small amount of grease in there. Now, when we talked about this armature shaft here on the motor, I want to show you a couple of little parts here so that they don't get lost, because I thought there was only one of these, and you see how it came off of here, and I thought there was one, but one had fallen off because it was stuck in that bearing. And then there's another one on the shaft, and I didn't realize there was two until I was putting the motor back together, got it all done, and then I found one laying on the workbench. I said, uh-oh. But there's another little piece here. You can see this, and it's kind of like a plastic. It's not metal. I don't believe it's metal. It might be some kind of bakelite. It's hard, and it's a thrust washer. So when the machine is put together and the motor's turning, you know, it wants to move around a little bit. So with that in there and these on, and then it being in the bearing, it kind of more controls the move. I wonder if I can run this now. Okay, the motor brushes, or carbon brushes, are in these brass tubes, and they rub up against the commutator, and you can see the black deposits that they leave on the commutator. And that's one of the reasons that I open the motor, is I want to clean the commutator, but I want to see how much the condition of the carbons and how much is left. Okay, so the electricity going through the core and the coils and the commutator is what makes it spin, the brushes on there. So let's see it in action. Maybe if I hold it real level here. Let me try it one more time. I'd love to show you how that looks when it's turning. Doesn't want to do it. I'm sorry. I shouldn't have teased you like that. So let's get back to disassembling this and looking at these commutators. Now, if you want, some people will just come in here and take, you know, a cleaner, or some people will use a spray cleaner, spray electric cleaner, and I know a guy who uses a brake pad cleaner, and they'll just hold it over something and spray it and let it drip out. And I've never been into that. Some people will come in and just clean this. Oops, let me tilt the camera back down here. They'll just clean that commutator in place because they don't want to dismantle too much and mess around with it. And that's fine. You know, it's not that hard to take off those two nuts and pull the cover off and just clean around in here once a year. What the heck, right? But I'm going to show you how to go a little bit beyond that. And I want to show you, in there is the carbon brush. So let's take a look at this here. I've got connectors, clip-on connectors here that bring the electricity to the brushes. Okay, so we can pull those off. And this is like a brush tube insulator that I don't know, it's kind of like a vinyl with some stiff coating, but it goes over this screw to hold on to. So when you pull the wire off the wire clip, you can work it up off of the screw like so. If we bring our wire up here a little bit, we can work this off, and then I can show you this is the brush tube. The brush is in there, and this is the spring end. On this end, the spring is in there, pushing the carbon brush against the commutator. So this is just an insulator to insulate that tube from the other parts of the machine, or the motor. Now you see a couple more nuts here that are holding this. This is like, reminds me of masonite siding. This is, you know, like some kind of a pressed fiber woody thing. I don't know what else to call it, but it's to hold the brush covers and keep them at the right position against the commutator. And if you want to remove or replace the brushes, some people will come down here and pry this end open with a screwdriver down here, and they'll pry that up and bring them out that way, and then bend that brass back down. And I don't like to do that because it never, I don't know, you can tell it's been bent, and I'm just worried it's going to crack or break or something. Let me take off these spacers and washers here, the thrusts, put them in my parts thing here. So we'll just loosen these nuts a little bit, and then we can take them off of the cover fastening screws, and we can just lift this little plate up and bring the brushes up with it. And then while we have that up, we can more easily clean the commutator if we want, and we can check the condition of the brushes and take them out and look at them, and you can see you know, how much of the brush is left, and make sure that they're not cracked or broken or something. Let me put that down there at the end. Got to get my finger on the end of that screw so it won't turn while I take off the nut. I want to show you one of these screws too, because there's no slot in the head of the screw, but behind the head it's squared off, and the hole it goes into is square, and that's what keeps that end of the head end of the screw from turning while you put on the nut here. And these nuts, of course, are the same as the two that go on the outside, the same size, same everything. Just gently fold those lead wires back. Now when you pull this off, the carbons are going to want to shoot into the center, right? For the spring. You see how they popped up against the shaft now? And then if you slowly bring them up, they'll kind of pop into each other. Well, they bypassed each other because I didn't do it level. I got this wire hung up on it. So let's just take a look at this for a minute. There is a motor brush, for those of you that haven't seen it. And you see it sits in there and it sticks out a little bit against the commutator. So this has more than half-life left, I would say. You can buy longer ones now. They make them longer nowadays. But for the original size, there is more than half left. And I have to say, I prefer the original carbons over what I'm able to buy on the market now, because they seem to be denser. They seem to be compacted denser, and I think they last a lot longer. So I would use these until they were like way down, almost to the spring. You don't want to let them get to the spring, because if the spring hits the commutator, you know, you got sparks and it can damage stuff. But I mean, I would use them way down before I bought new ones, especially like this. These have got miles and miles of sewing left. On the end of the carbon, there's just like a post sticking out, and there's a little spring. And you can buy the carbons without the spring, or you can buy them with the spring. And the brush number is 192457, and they're readily available. If you have a sewing center, they can get them for you. You can buy them on eBay and places like that. And I don't know, a pair's maybe $8 or $10. You know, so it's not like they're expensive. But for me, I'm sure I would sure use these up before I replace them. Okay, so you see this little kind of piece of masonite now with the holes in it, and the brush tubes are just crimped onto the wood, and that's what holds it. So it's a very simple system, and this is just to support the brushes right at the same height for the commutator. Okay, I'm going to put these brushes carefully aside so I don't damage them. Okay, so what I've got here is a couple of aluminum spacers now. And let me think about what these were called. Oh yeah, brush holder spacing bushing. So this is your brush holder, right? And that's the spacing for it to keep it at the right height. So those just slip onto the screws. Then you can take the screws out. You see how long it is. And you see the head here has no slot for any kind of a screwdriver, but on the back side of it here, it's squared off. And I know there's a name for this type of a screw or bolt head, but I can't remember it. I'm sorry. But where it goes into the pulley end of the cover, it goes into a square hole, not round. So that's what keeps it from turning. There's the other one. Okay. So now you see we can get a little better look in here. The core And these black taped up, those are the coils, and they've got a tape over them, like an insulating tape. On the PA motor, this pulls out very easy, but on this RF5 motor, it doesn't want to pull out. But I'll show you we can do more than this. But you can see the commutator with the carbon wearing on it. But again, if your carbon's not worn and you just want to get in here to clean this, you don't have to go as far as I'm doing. Now here's the wires come in, and they're just spliced with wire nuts. They're not terminated on screws and nuts or anything like that. They just put some slack in there. They have a strain relief crimp, and then they just have different size of wire nuts to splice the wires. And that's just like a permanent installation, no terminal to plug into or anything like that. I'll dress those up later. Okay, so on this pulley, you can remove this pulley, and I thought maybe it was like a compression pulley or something like that, but it didn't budge. But right in the bottom here is a set screw that holds the pulley to the armature shaft. So let me loosen that, and we'll pull the pulley off. And it can go either way. It doesn't have a certain way, and it's metal. And on the armature shaft, there is a flat spot that the set screw will go into, and that will prevent the pulley from coming off. So, if you wanted to push some wiring up in here to make slack, remember now this is all hardwired, and you've got some of those wire nuts have wires going right into the coils, and they've only got a couple inches of wire there, so you got to push wire up through the housing to get some slack. But then you can take off the pulley end of the cover, and you see it's got the same thing in there. It's got a shaft bearing and a retainer, bearing retainer, same kind of thing. But this one has a hole right through the bearing because that's where the shaft goes through, where the other end is a cupped bearing where the shaft rests down inside of. Right? Okay. And here you see the little fan. And this would be normally where I could, on the PA motor, you could, expose more of this. But it is so tight in here with these coils that when I try and pull the core, it's not coming past the coils, and I do not want to bend the coils or anything to let's see if I can try and get it out. There's no reason to get it out. I was just curious to see it, Okay, so if I, where's my little alcohol here? Like I said, now I have seen people who take, I think it's called CFC electric cleaner, and spray this clear fluid on there, and it kind of evaporates real quick, and it's supposed to dissolve this stuff and and evaporate into the environment, I guess. I don't know. And it's not expensive to buy a can of it. And like I said, I have another guy who uses a brake pad cleaner, which I think he said is like the electronic cleaner, but it's a lot stronger. But according to him, it doesn't hurt any of the windings or the wires or anything in here. But I don't know. I just, you know, for years have just used alcohol. There's not much in there but dust. The fan can pull stuff in there, and sometimes you'll see dog or cat hair or a spider leg or two or something like that. But mostly, to me, it's just the carbon dust from the wearing down of the motor brushes. So, you know, just to get that out of here while you have it open. But I like to clean this, and I see people who have done it with pencil erasers, and people who have done it with their Dremel. And a Dremel would be easy to use, that's for sure. But the thing is this should be very smooth and even. So if you polish it with a Dremel, it can get clean and shiny, wow, like a new penny, you know. But the problem is I don't know how even it ends up. And on big electric motors, they'll actually put this on a huge lathe with a knife and lathe it down a micron at a time until it's even. That's how important having it even is. So you see, alcohol gets some of that, but not too much. But I've just been in the habit of using a fine grade like emery cloth or sandpaper. I think this is 900. 400 is going to leave scratches. I would try and get up around 800 or 900. You can get even finer than that, but for the beginning of this, to me it's kind of too fine. So I just take that emery cloth or very fine sandpaper, and I'll wrap it there and kind of pinch it with my fingers. And if I had the pulley on here still, I could turn it, but I'll just try and back and forth like this, because I feel it's going to smooth it down evenly, because the pressure is being applied more evenly. You know, I mean, I could be fooling myself, who knows. And it does take longer than with a Dremel, and it usually doesn't end up as shiny as it would with a Dremel polisher, whatever. But I don't know. I'm very happy with this method, and I think it does a good enough job for me. Now you can also put it on your finger, you know, and go along with it. But then again, I'm worried that you're not going to end up even. Now, if it's uneven, of course, eventually the carbon brush will wear away and mold itself to the shape of the commutator. But I don't think you'll have as good a connection while that's going on. And I think it's going to have extra wear on your carbons and just wear them out sooner. So I probably should try the electronic cleaner. But you'll see etching on the commutator here from the brushes, and that's very normal. And if you see big electric motors, you'll see that too. And that's why they get to a point like the big electric turbines at the dams and stuff, where they'll do maintenance, and one of it is to take that commutator out and put it on a big lathe with a knife and spin that thing while they shave it down minuscule amounts until it's even. So that's looking pretty good for me. And let me do a little bit more over here, but I just feel that this method gets an even surface. You know, it gets off the old carbon deposits. I mean, that's kind of like why you used to clean your spark plugs and stuff, right? Because you get deposits on the metal, so it gets rid of those and smooths things out, and you have better contacts, so better flow of electricity and more efficient. Okay, I'm cool with that. Get my alcohol out of here so I don't spill it. And then to put this back in, we just stick the pulley end of the shaft down in there and line it up with the bearing, and get it started in there. And then we're going to pull these wires back down until these strain reliefs are all inside that housing. And there's kind of like just barely enough room for those 3 strain reliefs to get down in the base of that housing. Okay. And then there's room up here for the wire nuts and room in here. So I'll usually just start at this end. You can see how they were bent before, right? And the one in the middle I'll kind of tuck in the center back, and then this one, the front right corner, and this smaller one, see, you can pull some slack there, down in here also, like this. Make sure I've got the strain relief pulled in there. And then this housing part will cover the top of these wires, okay? So it's not like you have to jam them all down inside this part of the housing, because you have an equal piece up here. Looks good. Okay. So what was next? The carbon or brush tube, I call it carbon, they call it brush tube holder, is going to go on here, and we have to reconnect the wires. So I'm going to start my cover fastening screws back up, and they go from the pulley end towards the commutator end, and they come up right through a hole here, just like that, and then see, they fit flush in that little square hole. Okay, let's see if I can get the other one in there. So a lot of this is, you know, it's like the PA style motor that I did the series on how to restore, and I'll put a link to that series at the end of this video. But you know, the electric motors is basically the same. It's just like a different housing. So once you understand what these parts are and what they do, you know, like the smaller motor that goes on a lot of these 99s, I think the BY motor, it's going to be basically the same thing. It's going to have like a 2-piece cover, and the armature and the core and the coils, and you know, the shaft coming out, and some place it's going to have the carbon brushes in there. and I'm willing to bet that they're going to be in little brass tubes just like these are. Alright, I have both of the cover fastening screws through the pulley end of the cover and coming up here, and I want to put the little spacing bushings here just like they were. So it's just kind of like reassembling it, right? And then I'm going to end up putting this back on, and it kind of goes one corner to the opposite corner on those screws, right? And then it comes down, and the spacing busher spaces it just at the right height for the commutator. But ta-da, I need to get my motor brushes back in here, and of course the commutator's round, so the brush is going to be worn in a little bit of a C pattern. So you want to put it in the holder so that it's going to be that way again, where it's worn like that. You don't want to turn it at a 90-degree angle and then just have the points of that little shape rubbing along there, because you won't have all the power, and it'll wear all that down until it makes a new shape the other way. So it's better just to see how they are shaped, that curve, and realize that that curve is going to go on the round part of the commutator as it spins. So we'll put one spring and brush on one side tube, and then the other I'll just look at how it's wearing, and I'll put it in the other. Now we've got to get those back into the tubes while we put this down over the commutator. And I'll put one there and just hold it with a fingertip, and I'll make sure I got my curve lined up, the wear curve, and I'm going to hold it with the fingertip. And then you hold the motor steady for me while I put this back on, okay? There. Got to line up. Where's my other screw over here? Yeah. My screw's kind of fallen down. There. Okay, well I have one. I did pretty good. I got one brush the right way against the commutator, but this one popped back out. So let me show you another way. Is I'll take a blade, just a metal blade here, and slide it down in there, a thin metal blade, and use it to push that brush back in the tube until I can slide it down on the commutator like that. Okay, so now you see my brushes are against the commutator, and they're back in the shape they were wearing before, not turned this way. So that is good. Now I can put my the nut on the screw, pull it up and hold it, because that will hold the brush tube holder, that little piece of masonite. Get that down there, just finger tight for now. Make sure my screw is pulled up in the square hole down below. Okay, right, got my screw all the way in. Get this screw all the way in, and I can put the other nut up here. Huh. Darn it. Oh, brother. I should make a, let me try a different nut. I should make a blooper video, huh? See, that's really black. Well, they're all black. They should all be the same. I mean, they're all going on the same screw, right? I think the first couple threads of this screw are just smushed a little bit. There, you can see that better. Oh, so the screw head isn't all the way in there. There we go. Now that little square peg in the square hole, so to speak. Okay. So this whole tray brush holder thing is making sense, right? To keep the brushes lined up with the commutator. Put that back on and tighten it up. Make sure my screws are in flat. Yay! Now we want to put our wire clips back on the brush holder, because this is where the electricity will be coming to the brush or leaving the brush, however you want to say it. And it just slips on like that, but you want to be sure that it's snug. Sometimes when you've had them on and you pull them off, see how that looks a little bit loose, right? It doesn't really want to stay on like it did before. So without breaking anything, I'll put my little skinny needle nose in there and try. No, that didn't do it. So I'll just try gently flattening that back out a little bit, because I probably stretched them a little bit when I pulled them off. There. That feels like a snugger fit. So let me just do that on the green wire here before I even put it on there. Just compress them down a little bit. Not too much, because I still got to get it on there, right? I don't want to have to try and open them back up or something. Wonder how many millions of these motors and brush holders they made. Oh my gosh, can you imagine? I wonder, this was 1956, I wonder if they were still making their own motor. Okay, that's secure. Let me check this one. Okay, these are both nice and tight now. The commutator up. Let's put these the little spacer and washer in here, the thrust washers. So the little plastic or bait-like tube and the thrust washers. Okay. And now we can dress these cords up a little better now. I'm going to pull them down so the strain reliefs come down to the bottom and tuck the wire nuts in here. I want to get my little like insulators on here, the brush tube insulators. They tuck down in there like that. I don't put them back over the wires like they do. I just like them more like this. They're going to stay in place when you see the cover come on here. But you can do it if you want. You just put the wire through the little hole before you put the clip on. Okay, let's get that guy just tucked in there. So now you will see, wait, there's my alcohol. I do want to clean out that bearing a little bit and put a little some alcohol here. Let's see how that looks in there. See, it's very clean. Nothing really. There wasn't any grease in there, but I'll show you what I do, and then it's up to you. But you see that there wasn't any deposits or anything in there, but I just take a tiny amount. You don't want oil or grease to get up in the workings of an electric motor, right? And I'll just go in there and put that down in on the bottom where the shaft rests and around the side, and that's it. Now, let's see about putting this back together. Get my brush covers. Did my washers stay on? Yeah. I know that first time I lost one. Get my wires and wire nuts tucked up in the housing space for them. Get my strain reliefs pulled down. I have one of the wires a little bit pinched here, so I don't want it to get smashed against the side there. Let's see how the other one is looking. Oh, there are the wire nuts sticking out the side a little bit. I still got to get the screws lined up here and here. Get it coming through. The side with all the wires is, oh, see that popped that popped out again. See if I can get that tucked down inside there a little bit better. If I could get that screw lined up right there, that's the one that's not crazy about coming out. I think I got this side down too low. You got to kind of put it on evenly for those screws to be able to come out the hole. Make sure I don't have anything else pinched or coming out. Okay, get the screws, and there we go. Yeah. Once those come through, now the rest of these are all lining up evenly. The rest of the edges. And here's my pulley, or the pulley end. So, let's put the end cover fastening screw nut back on. And then we can tighten those up. And then we can put the pulley on and tighten that little dinky set screw. That's in the center valley. A little bit, a couple of turns on this side. A couple of turns on this side. Get it on nice and even. Then we'll go back and look at it. Everything's lined up nice and tight. Before I put the pulley back on, I might as well run it, because if something is wrong and I have to take it apart, I just have to take the pulley back off. So let's give it a whirl here. Sounds good, huh? Sounds nice. Now, as I mentioned, the pulley is the same either way, no matter which side of it. But you want to line up so the set screw is in this milled out area, this recessed area, because that's where it needs to be tightened. Get that loosened enough that it should go right on there. Okay. Start tightening it, and then I'm going to wiggle it to make sure I've got it in that depressed area, the set screw. Need to tighten it up a little bit more, because the recessed area there, see that? Can't go too far left or right. That means it's in that low spot. But that's just to keep it from flying off. It has to be tightened very securely against the shaft, or else, you know, if the pulley's loose, it's not going to turn the motor belt, and you're not going to be doing much sewing. So once you're sure that it's in the low spot there, I need to move this around to my dominant right hand. And move the camera a little so I can see better what I'm doing there. It's a small set screw. Alright, so, and still a little bit, see that play in there? I didn't get that tight screw, set screw. I'm had to go through quite a few of my screwdriver tips. Like my Chapman had just the right width for the thickness for the slot, but it was a little too wide for the hole, because the set screw goes below the surface of the pulley, right? Otherwise the top of the set screw is just going to chew up the motor belt. And my Chapman was too wide to go down in the hole of the set screw. And this is a good screwdriver, but it's still somewhat tapered. It's tapered more than the Chapman, so I'm nervous about damaging that set screw. That's why I'm kind of taking it easy and time there. Now let's see, is that tight against the shaft? Yeah. All right. Of course, the real test will be when I mount it back on cute and get the motor belt going to the hand wheel and everything. And she's all disassembled now while I'm taking all this stuff off, because then I have to clean the body. But I would say that is set to go. Unplug it so I don't forget. The RF5-8 amp motor that is on Cute, the Singer Model 99K. Thanks for hanging in and watching that, if it was of interest to you. And I hope that you'll stop by when you have time. And if nothing else, you might get a few laughs watching me bumble around, huh? Take care.